We are starting this block with Mr. Ved Prakash, staff data engineer at GitLab, who will talk to us in a presentation entitled Intro to GKE Setup to Airflow with Helm and Terraform. I would like you to give an excited welcome to Mr. Ved, please. The stage is yours, please.
Hi, good morning, everyone. Excited, and let's talk about some tech. So it's mostly data. So it's me, Ved Prakash. I work as a staff data engineer at GitLab. I've been there for close to 3 years, and it's pretty exciting over there. So wanted to share some lights of what my learning and how we have set it up, the Airflow in our system and data platform team, with you all, the wider audience. So that's me. So just a little bit about GitLab as a company. So our mission, everyone can contribute. So just as we discussed before, we can contribute, you can, everyone can, everyone across the team, across the globe can contribute to GitLab to make the product better, efficient, and smart. And GitLab lives with the credit values, and this is not just the words. So it comes from the collaboration, results, efficiency, diversity, iteration, and transparency. Of this, every letter itself is a big handbook page in our GitLab terms where you can read more about this, but we literally live with these values. And it shows in our day-to-day work, every OKR or every goals what we do, or every project we deliver, it's through this value. It's transparent. We do in small iteration our development, and it's fast. And we deliver it, and we iterate it faster. So it's boring solution, but we iterate and make it smarter, but we meet the results at the end. So coming to what GitLab is doing. So GitLab is a DevSecOps platform delivered as a single application to help you iterate faster and innovate together. So it's a DevSecOps platform where everything can be done in terms of CI/CD pipeline, in terms of security of your pipeline and your Git repository and all the things. Now, moving to the next, to the agenda that what we're going to discuss today in this small talk time of 20 minutes. So we will be discussing about introduction to Google Kubernetes Engine, Apache Airflow, Helm, and Terraform, how all of these components fits together, and how the installation is done within GitLab data platform teams, and what's the win of data platform on this, and a little bit on best practices and considerations. So to start with, so introduction to GKE. What is GKE basically? Most of you are aware because of it, but just to reiterate, it's a Google Kubernetes Engine is a managed Kubernetes service that simplifies containerized application deployment, scaling, management on Google Cloud, offering a robust and efficient platform for container orchestration. What are the key features? So why we choose, so what's the reason of using GKE? The major was that it's a managed Kubernetes, so we don't have to manually manage the whole Kubernetes infrastructure. It's managed by Google, so it's more reliable. Automatic scaling, which was very much needed for our Airflow, the data pipeline, what we have built. We need a system which is automatically scaled on demand, whenever, and to handle all kinds of load what you want. Security and compliance is one major thing. So when you set up an infrastructure for data pipeline, it takes a lots of time to just cater around the security and compliance, that is meeting the security, is the firewall proof, is it exposed to the public internet, are we having a data leak happening like this? So GKE helps a lot in that, and that's why, and the integration at the last, the key features. Integration helps a lot in terms of integrating all our data sources, which is sitting on the other Google Cloud platform. So it can integrate with our other, we do a VPC peering where we interact with production databases. So we don't have to go over the internet and all, it just works with the VPC. So our firewall and all, just we do VPC peering instead of exposing of over the network to say, pass the data on. And few use cases, it's a microservice deployment, continuous integration, CI/CD, and a scalable application. So microservice deployment is a service which you have web servers, so what do you say, middleware and database, everything, it can be used for that. coming to the next, what's Apache Airflow? Apache Airflow is an open source platform designed to programmatically author, schedule, and monitor workflows. So this is a common tool used for scheduling. We have seen lots of tool for do a schedule like Control-M, Skybot, and all, but Airflow is one of the favorite for me because it helps a lot. It's open source, first thing, and it can be scaled to whatever design we want to. So what's the key features, again, for this? So it comes with the directly acyclic graph, that's called DAGs, extensibility, the way it's helped to extend whole Airflow pipeline, dynamic workflow execution. So we have one DAG which can create like 200 tasks dynamically on demand. So whenever we just want to add one additional data table, we just add to a YAML and Airflow takes care of it by creating a task for that. Rich UI, which I like it, and the logging capability, where you can log it, you can see the logs in the UI, but also you can see it back in the server. A scalability, so you can have a multiple web server to handle your loads, incoming loads coming in from using the load balancer. You can scale your web server, you can scale your scheduler, you can scale your database, so that helps in this. The top use cases which came to my mind was data pipeline orchestration. That's what we generally use it for. ETL, extract, transform, load, process, not doing the ETL, just scheduling it. Workflow automation in diverse industry. What's the Terraform then? So we talked about GKE, we talked about Airflow. So what does the Terraform do? Terraform is infrastructure as a code for GKE, and it's an open source infrastructure tool that enables user to define and provision infrastructure using a declarative configuration language. The key features, as you all know, is the infrastructure as code, so that's a good for versioning control and all, multi-cloud provisioning, so it can be work on Google, Azure, AWS, declarative configuration language, so it's very simply configured, easy to configure and make it easily readable for anyone to apply it. Plan and apply workflow. This is the best part. You do a Terraform change, you can validate, you can plan it, that what's the plan? How will this go and implement in the system? Will it destroy something, what it will change, what it will add? And it's easily readable, and that helps you a lot to judge that shall I go and apply these changes to the production or not? You can figure it out if something is wrong. If your file has changed, or the target server has changed manually, it will throw you an error that something has gone wrong. Your plan is not looking what you have done the modification. So it gives you a more control. And this is the best way, I feel, to handle our infrastructure. And the state management. So this is something which helps, like you have a team of 5 developers and everyone doing a Terraform change. How do you keep the things in sync that I have done a changes, added a node pull to the cluster, and you are adding another one? Then how do you do? State. A state file is the one which helps us to pull up the configuration of the GKE from the remote, our GCS bucket, that's where we store it, and to know that what is the current state of the GKE, looks like it was the last one, and then what the changes will do. Will it modify, will it destroy, or will it create a new, add something new to it? So that's the state management. That's one of the more useful key features where you can manage from a point, where you can roll back, where you can control it. The use cases, coming to the use cases, it's provisioning servers, network infrastructures, application deployments. So it's used for everything, but we have extended it a little bit. So we can install Airflow using Terraform just without having Helm, but we used Helm, a package manager for Kubernetes, because it makes our life easier. It's a package manager for Kubernetes applications, simplifying the deployment and management of containerized application. So what Helm help us in that, we have a consistent deployment across all the environments. So if we have 5 GKE clusters, one for test, one for dev, we can use the same features, same package everywhere. So we don't have to have a different, so we keep our environment sync, that nothing is different in the test or nothing is different in the prod. It's the simplified configuration, so you have a basic Helm configuration which comes with the Airflow, and then on top of it, we modify our configuration, like having a different secret keys and all, Fernet keys, so that we keep our web server secure from the outside world, not using the default setup. So there's lots of, we use Postgres database in the backend. So all those things is being useful over here is the Helm package. We override it with those values with the config management. And the dependency management of the packages. So you need to install the database first, then the sidecars first, then web server, then the scheduler, and then the web server. So this is all taken care by the Helm, rather than us, if I had to do it using Terraform, just using kubectl, I would have to ensure that everything goes on the pieces, otherwise it will just go haywire, it will not work as expected. So use cases is a microservice deployment. In this case, we are using for Airflow. So integration of Airflow with GKE using Helm and Terraform. Why use GKE for Airflow? Why not anything else? There are lots of benefits for this. The major one is that it's scalable. So it's going to scale to your demand. You can have for different workloads, you will have different node pools dedicated, so you can handle a data science model in a different node pool with a bigger machines, with a bigger GPUs in the same cluster. And you can have a small pipeline also running in the same cluster on the smaller node, with a node pool with a smaller machine. So you don't pay way high for everything, like running on everything on the bigger machine. So that's the one on this. Then the next one for this, why for the Apache and GKE is on the scalability is done. Then the security. It's secure. We host our Airflow on the VPC, private VPC, and that's where we keep it safe from the outside world, our Airflow instances. The third point comes to this for the Airflow and the GKE. This, why we are using it, why it should be used for this is ease of maintenance and ease of maintaining the whole infrastructure within the GKE platform. The slide's gone a little haywire, sorry about that. Yeah. So why Helm charts for Airflow? So that's the question. So we asked why GKE for Airflow and why should we use Helm charts for Airflow? The ease is that it's a standardized packaging. It will help you the consistent deployment across all your different environments. So that's one of the major thing to have. Main benefit for Helm is to keep the consistent deployments, simplified configurations. So you have a simple configuration. So you have a basic config, and then you override. So you can override your configuration based on your requirement for a test environment. You can have a different setup. You can have a different config management for production. You can have a different for your performance test environment like that. So that's the thing. Version control and rollback. That's another benefit of Helm charts, that it helps you to control your version and your version in the Git repository, and that's easily managed. And the reusability, of course. So it's a shareable configuration. You can configure it you can share it with all your team members, and anyone can contribute to that to help it. So that's the other thing, why to use Helm for the Airflow. We have been using before Helm normal deployment, but this was when the Apache officially released the Helm chart. It made our life much easier because the upgrading to the Airflow and all, it was much more smoother now, rather than manually doing the upgrade earlier. And why Terraform module for GKE? So with the Terraform module, you can have everything configured just outside, not doing it manually. So in case something goes wrong, like accidentally you drop the cluster, you have a Terraform model which can just bring back the cluster in like 30 minutes. With all the big machines and all the setups, you run the Helm charts on top of it, and the whole machine is back for nearly like 45 minutes of time with all the configuration and all the things in place. Moving to next. Now let's connect the dots between the GKE plus Helm and the Terraform plus Airflow. So we provision the infrastructure with Terraform, so that sets the base. Terraform sets the foundation. It bootstraps the Kubernetes clusters with all necessary firewall rules and all the things in place. All the VPC pairing and all done through the Terraform. And then Kubernetes cluster orchestration with GKE. So GKE ensures the seamless operations between the pods of the web server, the scheduler, the PG bouncers, the Git repository, and Git sync sidecars as well. So that's done by the Terraform, and then the Kubernetes plays the role of that. And then we do the package management with Helm. So Helm charts defines the Airflow configuration. As I said, it makes the server like spinning up the server becomes much more easier. If anything goes wrong, you can easily track it down. And when you do the Helm chart deploying on GKE, this is the favorite part for me. It's a smooth deployment. You just run it, apply, and then just sit back and relax to see that it's going good, or it's what's happening. And if anything breaks, you get the proper error. So something is there on the screen. Sorry. Yeah. And last comes, so when you deploy the Helm charts, your Airflow is up and running. And that's the last bit, integrated workflow. And that is the orchestration with the Airflow. So integrated approach, the integration with the Airflow helps you with all your job data, workloads and everything. And with this, at the end, you have Airflow up and running, which has all your active DAGs. With the Git sync, we are continuously syncing our Git repositories with the Kubernetes server over there with the Airflow. So any changes we do to our Git repository, our analytics data repository, after testing is done, when it's merged to the master, it instantly, like in a gap of 2 minutes, it syncs with the production. And you can see that DAG in the production. Over there, you can run it instantly. By default, it's off, but you can run it. So with this, all the 4 things in place, you have an infrastructure in place with the combination which is safe, secure, reliable, scalable to the core, where you can scale it to the amount. And it's a very cost-optimal solution. So when we run a data pipeline, sometimes it's become very costly process. If you use like a standard VMs, and you don't have, if you need to scale it, then you manually go and add another VM to it, and then you have to shut it down. But GKE take care of auto-scaling, up, down, everything of that. If you need to horizontally scale, you can scale as much as you want on demand, and then you scale down to 0. So we don't run all our node pools 24 hours. We just run the standard node pools for Airflow for like 24 hours, because that's where the Airflow is hosted. But remaining all node pools are just scalable from 0 to 5, 0 to 10, based on the demand. We do handle our data loads for data science, data scientists. We run data models, our data pipelines, the DBT, the heavy data pipelines, which exports like close to 100 GB of data every day. And these all happens using Airflow. And this is the benefit of the GKE, that it helps a lot to scale up. And the good thing with this, all of these things coming together, is that the GitLab CI/CD pipeline. The CI/CD pipeline is so robust that when you modify your YAML file for Terraform or for Helm, it validates, it does the proper validation, and if the CI pipeline passes, it revalidates that your plan will work perfectly or not, and if it will give you an output how the plan looks like, and based on that, you can take a call, should I deploy it to production or not. So that's the whole connection of the dots between the GKE, Helm, Terraform, and Airflow. Moving to next. So how it is done within GitLab. So GKE cluster is provisioned through Terraform using Helm charts, and we have the Airflow installed through the Helm chart. So we have 2 namespaces within the same cluster, prod and testing. We have 7 node pools, different machine type for each node, as I said. So we have for bigger machines with big GPUs and CPUs for data science models. We have big machines for heavy data pipeline, where we export like in one, where we run like hundreds of jobs within an hour. So at that point of time, we need a bigger machine with a scalable capability, so it can scale as much as we want. Remote state for any changes required for the GKE cluster. So we maintain our, as said earlier, we maintain our state file in the GCS, which is properly secured and safe, not open to the public. And that helps us to maintain our version control of the whole of the GKE infrastructure as well. GitLab CI/CD pipeline to validate the changes done to the Terraform script. This ensures the changes will not break the Terraform apply. So this is the most critical part, which helps a lot in order to not destroy our whole GKE setup of the Airflow. Because this is the bread and butter for the data engineers. If that Airflow goes haywire, the whole data pipeline goes haywire. And then you have lots of questions to be answered. Airflow installed using Helm charts. So we use Airflow version 2.5.3 using Helm charts for Airflow, which will bootstrap an Airflow deployment on Kubernetes cluster using Helm package managers. We use Cloud SQL Postgres instances, so that we have configured our basic config to use Cloud SQL Postgres. And we have a sidecar used within the Kubernetes pod, which do the Git sync with the analytics repository. So that's where, this is the one which takes 2 minutes of time to sync the Git repositories, keep polling the Git master branch to see that any new commits has happened. And if something has happened, it will pull it, and you can see that DAG immediately into the Airflow. And we have modified our web servers, secret key and the founded key. These are the default keys which comes with the Airflow installation, but it's good to have your own if you are using it, because this keeps your servers safe and secure. Because with default one, people can decode it and they can get an access to the Airflow UI. So how this benefit the data platform team managing the data pipeline? So we currently have 88 active DAGs. With these 88 DAGs, we are able to run 1,200 plus tasks every 24 hours. So this is a huge number in terms that there is a DAG which runs like 300 tasks, and it runs for 1.5 hours. And these 300 tasks is nothing but polling Postgres database with 300 tables. And this is done with the help of node pools and the Airflow pools as well, so slots within the Airflow. We use Airflow slots to say that use a concurrency. You can run 10 tasks or 15 tasks within this particular Airflow DAG in a concurrency. And if you set it to too high, then your node pool should be able to support it. So that comes the GKE, where it scales horizontally to have like 6, 7 clusters to handle that load. And that's where one task itself creates like, one DAG itself creates like 200 DAG tasks, and that is through YAML files. So we have just 88 Python files, and that 88 Python file is responsible to create more than 600 to 700 tasks in the Airflow. Improving the workflow task dynamism with Airflow. Since, as I said, it's configurable, so once you do a modification, and it's makes life very easy, because as a data engineers, we are always overwhelmed with lots of work, or lots of our own pipeline. So someone needs to add a new table to a Postgres. A person who is requesting can himself add it, and add it to the YAML file, and we can just see, validate it, it looks good, and we do the merge request. And that file, that table is present in the pipeline in after 2 minutes. So it enhances the CI/CD timeline and the deployment timeline for adding a new table. So Kubernetes pod operators schedule dynamic workload. So Airflow comes with the Kubernetes pod operators, and that is the one which we use to schedule our workloads in whole of the GKE setup. So every task spin through Airflow creates a pod in the GKE, and that pod itself is responsible to do that, whatever that task was supposed to do. So right from establishing the connections to the database, pulling the data, pushing it to GCS, loading to Snowflake. And once all is done, the pod gets auto-destroyed, and then the machine starts scaling back. So Kubernetes pod operator is like lifesaver for us, because it helps us to scale the whole environment. On-demand node provisioning with Terraform. So with Terraform, if a team comes with saying that I need a machine, a data science team mostly, I need a machine with a bigger spec now. And if we were going through UI and we didn't have Terraform, the problem would be that how do you manage this? You have to again go through how do you version control. So with Terraform, it's easy. Okay, you need a machine. Let's go add the spec, set it to this. Go from n-4 to n-8, like that, merge, it's validated within half an hour, and it's, boom, ready to deploy in production. You have new machines present to do that. Minimal downtime, typically under 45 minutes in the event of disaster recovery scenario. So that's what I was telling in the start. With this, all the four setup, if we destroy the whole of the Kubernetes, everything, and everything just goes wipe off, we can spin it back in 45 minutes. So with this, it makes like the system is in control. So in the case of worst to the worst, we are back in 45 minutes to resume the pipeline, and which helps our data pipeline to be more secure and reliable for the end users. The best practices and consideration. So security best practice, private cluster configuration, that's what I would recommend. VPC pairing. So if you have another database, another sources which is in the same Google Cloud, you try to do VPC pairing rather than exposing it over the internet. and fetching data to there. Identity access management control, which is something like to give the least privileges to that so that only people with minimal access work with the minimal access over there. Node pool isolation for different data load, have a different node pool. That will help you for different type of work, just have a different node pool. So this will keep your costs down and you'll not be running a bigger machine for a smaller task and a smaller machine for a bigger task. Securing secrets, so everything is in the vault, so use it vault to secure our secrets. A scalability consideration, horizontal pod auto-scaling, so that's one which is recommended. Database scaling as well, so you can scale your database as much as you want. Task parallelism. So concurrency within the Airflow helps you a lot to how do you run your task in parallel with each other at one point of time. Resource request limits, persistent storage consideration. So this is something where you have like as GKE, you should have a PVC volume as attached to it where you can store all your logs. So in case GKE goes off, and when you restore it back, you still have access to those logs to see for. GKE node pools for different types of load, for different streams of team to work with. Monitoring and logging strategies, leverage Kubernetes monitoring solutions, Prometheus and Grafana, which is very useful. Alerting and notification channels, we use Slack for all our Airflow failures happening through, and we monitor our web server through Prometheus and Grafana, and if it goes off by any time, we get an instant alert, and we use Airflow metrics to monitor it. And this is me. You can just find me and look for me and just reach out to me. And there's some additional resources. So we have GitLab handbook for information about node pools and namespaces, how we have set it up, Airflow infrastructure, how it is present over there, and our GitLab data analytics repo or our data bags where you can see all the DAG bags, all the DAGs, how we have done it. And thank you. And any questions, please?
Thank you very much, Ved. Now we have a couple of minutes for questions.
Yeah.
Please, question here and there.
Hi. Thanks for your presentation. I was wondering, when choosing Helm, have you considered customize as an option?
No. We just looked at Helm because in our organization we were using a lot of Helm config management, not for our infrastructure, but the site SRE team, they use Helm config management a lot. So we took the knowledge from them and imported it in ours so that to keep it consistent across the organization. So we haven't looked to that. But yeah, it's if we chance to there, we would have evaluated it again. But Helm was the choice because the Apache Airflow, we were waiting for it to release a Helm chart, and when it released with the Series 2, it was good because it was helpful for version management and all, so very easy for the upgrade of Airflow.
I see. And sort of related to that, do you see any advantage having your own Airflow deployment compared to maybe Cloud Composer, which could be kind of simpler?
Yes, we see an advantage. We can manage our own. We see advantage in terms, we want to, our load balancing and our, whatever the demand, what we have in terms of the data and the node pools and the machine size, it's much more easier for us to manage it over here on this side. Cloud Composer is good, but it's a lot of pain for me or to think that to sync my Git repository every time I do a modification. So the CI/CD, when it works with the GKE, with the GitLab, that component helps a lot in our data pipeline to make it much more scalable. So that's where we look at the level that how GitLab works with the GKE more efficiently with all our CI/CD pipelines set up in place. So that's where, so yeah, Cloud Composer was an option when we were looking at managed service, and then we still stuck with this because we were able to manage all our loads over here. So,
thank you.
All right, we have space for one more question. Yes, please.
Thank you. Hi. Thank you for your time. The question was regarding the Docker itself used with the Kubernetes.
Yeah.
What's the key difference between using this approach and simply using officially available Airflow Docker image with the nodes on the Kubernetes?
Yes. So we were using Docker before. So we moved to Helm with the Series 2. We were till Airflow 1.5, we were using Docker images. But when we were trying to do an upgrade from 1.5 to 2, Docker image was creating lots of, stale objects, our hanging DAGs. So it was not a performance oriented for us. It was working good for other people, but we saw that couple of blogs saying that the DAGs are hanging and there is stale task which is waiting for to be executed for 24 hours. So Docker images didn't work so good for us, but when we moved to Helm, it was working good. I'm not sure what was the difference, but at that point of time, for me, the performance was the key to move towards the Helm. But I had a problem with, till 1.5, it was super good. It was very efficient. It was good. With the Series 2, it didn't work good for us.
Great, thank you. So basically in future, it might come back as a possible solution.
Yes, yes,
Thank
it
you.
is. It is still never away. We use Docker for our local testing. So we still use the Docker images for our local testing for this.
Thank you.
All right, Ved, thank you very much for this insightful presentation. I would
Thank
like to
you.
remind everyone that you can network and connect during lunch, perhaps for future questions. And this is a certificate of appreciation from the organizing team.
Thank you.
Thank you very much.
You.
Thank you.